Okay. Test 2 review. So this test is going to cover modules 3 and 4. So that's polynomials, rationals, exponentials, and logarithms. All done? Do you want more?
No.
Say please.
Please.
Here you go. So let's start with polynomials. Given that 6i is a 0, write the polynomial in factored form. So a note that if 6i is a 0, so is negative 6i. And then I know that I've said this probably a dozen times, but I always graph these. Always. And try to get whatever I can from the graph.
I did, Mama.
X
Mama?
to the 5th. What do you say? You're not done with this one. You're not done. Oops. Ugh, what did I do? Start again. X to the 6th minus 10x to the 5th plus 58x to the 4th minus 354x to the 3rd. That was a minus, not a plus. $765 x to the 2nd, 216x, 972. There's a lot going on in this one, so I want to double check. 72 plus 216x, 765x squared, 354x to the 3rd, 58x to the 4th, 10x to the 5th. So the goal of graphing is to try to get more zeros. Oh, there's one. There's another. Okay. So it looks like I have 2 more zeros. I do. I have a 0 at -1 and another 0 at 3. So now I'm going to do synthetic division, and I'm going to take out all the zeros that I know. That is the 6i they gave me, the negative 6i that I know because it's the complex conjugate, the -1 and the 3. So we'll do that with synthetic division. 58, -354, 765, 216, -972. Okay. I'm going to start easy with the -1. -1, positive 11, -69. So -354 minus 69, -423. That turns to positive 423. That dog is adorable, but he's really like going to cause my dogs to go insane. Because he does not know how to stop barking. So if you hear the ruckus behind me, that's why. 3, -8, -24, maybe 45, 135, -288, 324, 972. Okay, those were the easy ones. Now let's do 6i. 1 times 6i is 6i. 6i and a minus 8 is a negative 8 plus 6i. Again, you'll like see how I was doing all that in my calculator because I'm not even going to pretend that I would do that perfectly without the calculator. So 6i times negative 8 plus 6i. Negative 36 minus 48i. And then we add 45 to that. Put this over here so that I don't have to keep moving it. There we go. So now I have 9 minus 48i. Multiply that by 6i. 288 plus 54i plus a negative 288 would bring me to just 54i times 6i, negative 324. And then last but not least, I have a negative 6i. So 1 times negative 6i is negative 6i. 6i and negative 8 plus 6i minus 6i is just negative 8. Negative 8 times negative 6i is 48i. 9 minus 48i plus 48i is just 9. And then 9 times a negative 6i is a negative 54i. Phew. So if we started with u to the 6th, then this is 5, 4, 3, 2. So what I have here is a 1u squared minus 8u plus 9. I want that to factor, but it doesn't. Right, you're like, ooh, 9 and then 8, that would be 9 and 1, but there's no combination of a positive 9 that would multiply to a negative 8 because you would need negative 9 and positive 1. Then that would give me a negative 9, so that doesn't factor. Moral of the story, this doesn't factor. So when it doesn't factor, let's use the quadratic formula. So what I have here is u squared minus 8u plus 9. So negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Let's see. Negative 8 squared 4 times 1 times 9, 28. The square root of 28 reduces because 28 is 4 times 7, and the square root of 4 is 2. And then I can divide both an 8 and a 2 by 2. So then my final answer is 4 plus or minus rad 7. Okay, so if we're writing this in factored form, I would have, let's see, u minus 6i, u plus 6i, u plus 1, u minus 3, and then I'm going to bump up to above the box because of this stupid thing. U minus 4 minus rad 7, and U minus 4 plus rad 7. Okay. Oh my God. So the function with the smallest degree, okay, well here I have x equals -2, and that is multiplicity 3. We know that that is multiplicity 3 because it is curving. Here I have x equals 1, and that is multiplicity 2 because it is bouncing. And here I have x equals 4, and that is multiplicity 1 because it is crossing straight. Okay, so let's turn that into an equation. This should have been v's instead of x's, but you get the point. I have v plus 2 to the third, v minus 1 to the second, and v minus 4 to the first. So then the other thing that I need is a leading coefficient. I see 2 good points I could use. I could either use 2, 4 or 0, 1. So let's do 0, 1. So here, I'm going to say m of v equals, we don't know the leading coefficient, so I'm going to put a in as a placeholder. And if I plug in a 0 for v, I should get a 1 for y. So I have 1 equals a times 0 plus 2 cubed, 0 minus 1 squared, 0 minus 4. A times 8 times 1 times -4. Right? 2 cubed is 3. -1 squared is 1, and then just the -4. So -32a. So then I have -1 over 32. So then my final equation here would be -1 over 32, b plus 2 cubed, b minus 1 squared, b minus 4. Okay. H of u equals, it's factored form. Okay, the degree of h, when we have degree in factored form, we add. So 4 plus 2 plus 3, that's 6, 7, 8, 9. Now for the leading coefficient of h, we're going to do the 0.083 that's in front times all of my coefficients with my power. So times -3 to the fourth times 2 to the second times 3 to the fifth. So again, that was this 2 to this 2, this 3 to this, that was a 3. .083. Oh, I missed my decimal point. -3 to the fourth, 2 to the second, 3 to the third. So that's my leading coefficient, 726.84. Okay, so that was positive. So a positive leading coefficient and an odd degree means that my end behavior looks like that. So on the right, as u approaches infinity, h of u also approaches infinity. As it goes up, as it goes right, it goes up. And as it goes left, it goes down. Okay? To find my u-intercepts, I set each factor equal to 0. So this would be 10 minus 3u equals 0. Negative 8 plus 2u equals 0. And 3u minus 5 equals 0. Then we'll solve each one of them. So 10 equals 3u, and u equals 10 over 3. They want 3 decimal places, so two u equals 8, u equals 4, 3u equals 5, 5/3, 1.667. So I have 3.333, 0, 40, and 1.667, 0. And then my h of u intercept is when u equals 0. So I'm going to come back up here. And I'm going to say 0.083 times 10. Now this minus 3 times 0 is going to go away. So 10 to the 4th. And then negative 8 to the 2nd. Because again, the 2u there is going to go away when I make that u 0. And then 5 to the 3rd, because again, that 3u will go away when I make u 0. 6,640,000. Okay. Given q of u equals, answer the following questions. Okay. The domain of q is that it is a real number and it does not equal -6, -4, 6, 0, or 6. Remember, the domain is determined by my denominator. What can I not plug in? I can't put a 0. I can't put a 6. I can't put a -6. I can't put a -4. I just put them in order because that's what you're supposed to do in set notation. I'm going to write the interval notation over here because that little box is not going to be enough space. So it's going to be -∞ to -6, -6 to -4, -4 to 0, 0 to 6, and 6 to infinity. Okay. Let's reduce. You should always reduce first. So here, my w minus 6's will cancel. That means that I have a whole at w equals 6. So I'm going to make a note down here. My w plus 6's will cancel, except that this 5 is going to become a 3. because if there were 2 down here and 5 up here, 2 of them will cancel. When you have more left over on the top, then that's a whole. Now, these W's will cancel, but I'll be left with 2 of them down here. And when you have more left over on the bottom, that's a vertical asymptote. So then my vertical asymptotes of these numbers, my vertical asymptotes are the -4 and the 0. And my holes are the 6 and the -6. And so then they want an ordered pair. So to get the y value, you plug these into the reduced function. So reduced, I have on my top 4 times 6 minus 2 to the 6th times 6 plus 6 to the 3rd. And I think I put too many in front. I did. And on the bottom, I have 6 squared. That's gone away. That's gone away. So 6 plus 4 to the 3rd. So I have a hole at 786, 432. -6 is going to be easier to plug in because when I put in a -6 right here, I'm going to get a 0. And so my numerator is going to be 0. And then it doesn't matter what the denominator is, the whole thing is 0. Okay, so again, you're going to take these and plug them in to get your y values. Now your w-intercepts are going to be the places where it crosses the x-axis. That is based on your numerator. So here we have this right here would give me an intercept at 2, 0. And then you want to say -6, 0, but -6, 0 we just said was a hole. And it can't be both a hole and an intercept. Your Q of W intercept is going to be where W is 0. So I have 4 times 0 minus 2 to the 6th. I really could have just done second enter. I'm going to make my life easier. And change this to a 0. But wait a minute. If I change that to a 0, I would have a 0 in the denominator. That means there isn't one. Never asked me. Oh, okay. Horizontal asymptote is down here. So remember, the horizontal asymptote is based on degrees. So we need degree of the top and degree of the bottom. So after I reduce, I have 9 on the top and 2, 5 on the bottom. So that means this does not have a horizontal asymptote. It means it has an oblique asymptote. And if you have a positive leading coefficient, which we do here, then your end behavior is going to look like this. So on the right side, as W approaches infinity, Q of W also approaches infinity. And as W approaches negative infinity, Q of W also approaches negative infinity. And that's our polynomials and our rationals. Let's take a look at the logarithms and exponentials. I'm going to pretend this isn't here for a second, and I'm going to expand this as much as possible. An eighth root would turn all of these into a fraction over 8. So t to the 11 over 8, y to the 3 over 8, r to the 6 over 8. But I'm going to make 6 over 8 3/4 because that's going to bother me. And so then that would be log base 8 of t to the 11/8 minus log base 8 of y to the 3/8 minus log base 8 of r to the 3/4. And so I'm going to take each one of these out, and I'm going to make it 11/8 log base 8 of y, 3/8, wait, t, why did I say y? T, log base 8 of y, 3/4 log base 8 of r. Okay, now I know that log base 8 of t is 0.999 or 9.99. 3/8 log base 8 of y is 4.78. Log base 8 of r is 6.1. And now it's calculator work. Nice. Okay. A bacterial culture starts with 860 bacteria, grows at a rate proportional to its size. After 4 hours, there are 3,440 bacteria. Okay. So we have A equals PE to the RT. So we don't know the rate. We do know that after 4 hours, there are 34. So 3440 equals 860 E to the 4R. Divide both sides by 860. So then the ln of 4 equals 4R. So my rate is 0.3466. So then I would say that P of T is 880 E to the 0.347 T. So after 8 hours, 14,128.11. 113. How many hours will it take for the population to reach 1,230? So divide by 880. So then the ln of 1.3977. So the ln of that divided by point, just under an hour. Solve the following equation. As I know I've mentioned, anytime you have an exponent in a variable, you're going to need to turn this into a log. So first we have to isolate the e. So we wind up with negative 30e to the 14 plus 3 equals 53.8. Oh, that was dumb. 53.8 minus 15. And divide by the negative 30. 14t. So then this would become the ln of 78.96 equals 14t plus 3. And then we would subtract the 3. And my exact answer would be the ln of 7.78.96 minus 3 over 14, like that. And then my rounded answer four decimal places. Last but not least, anytime you have an x inside of a log like this, you're going to have to turn this function into an exponential. Before we can do that, we have to combine these logs. So when we add, we multiply. So that would be x squared plus 2x. And now I turn this into an exponential by saying 5 to the 9th equals x squared plus 2x. Well, 5 to the 9th is a very large number. So I wind up with x squared plus 2x minus I could attempt to factor that. I don't want to. So I'm just going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c 2 times a. Okay. That's 2 squared minus 4 times 1 times a negative 1953125. 8. I wonder if that's a square root. I wonder if that's a perfect square. It's not. Oh, oh, good. They want decimals. That helps. Because now I don't have to try to reduce this. Four places. So I split it. Two, 7. Oh, I inverted those numbers. It's 279. Did it once and then followed it all the way through. Okay, easy enough to fix. So then that would be 297, 279. Inverted them again. Divided by 2. 2, 8. Ugh. Seven, 5, 3, 8. Oh, it was annoying. Now, a side note. This is extraneous. And this is my only answer. Remember, logs have a domain of only the positives. So we can only put a positive in. And since this is just x, I can't put any negative numbers in. So that's my only answer. It's an ugly answer. But it's the answer. Okay?